Greetings, friends. Welcome to summer term of 2026. I wanted to start with the fact that we had our little Wanderers celebration last night. I took these pictures for those just joining us. The context here is the boyhood home of Linus Pauling, this gentleman here who is an Oregonian from the state of Oregon, and he was a prodigy, a child prodigy, you could say, in that he taught himself chemistry in such a way that he could become a teacher of the topic really pretty early in his career at very high level. Like, he's a major breakthrough kind of guy in terms of chemistry. And we meet in his boyhood home, by which I mean, when he was like 8 years old through high school, kind of, before he took off for university and never came back, I think we could say. Actually, I don't know his bio in huge detail, and that's something I'm still exploring. Like, I'm not completely unaware of his life story by far, but there's always more, and that's kind of a theme around here. There's always more to study, to learn, and there's a natural curiosity. But who has time, right? A lot of us are really busy, especially if we're like midlife and top of our game. You could say you've got a job, you've got a family, maybe that's your situation, maybe not. But the question is always one of time management, scheduling, and so on. And this slideshow, which I have not yet put out as a public show, I'm just making it right now, today, this morning, the day after our solstice gathering at Wanderers. You'll notice that we're we're older folks. Most of us here were I don't know, above 50, maybe above 60. Some are above 70, some are above 80, but very active and curious and into science and engineering, kind of STEM topics, but not exclusively so. We have radio broadcasters, film studies people, artists, people into AI, people not into AI. I mean, it's just, a full spectrum of people come to these gatherings, but it's, not heavily advertised, kind of word of mouth kind of thing. I'm talking about the Wanderers, which you can read more about in a listserv that's public archive called Synergio, which is at groups.io. So for more background, I suggest that. So this is called Synergetics for Seniors, this slideshow, and I really do anticipate presenting it to seniors, older folks, and I'm going to start with the bio slide, which that's actually a non-alcoholic version of the beer, the artichoke, or that's not an artichoke, what am I saying? That's the, what do you call it, hops on the can there, with piece of a fuller projection, Dymaxion projection behind me. And, depending on how long I have and where people want to go, I can go into more auto bio here. I've got in the slide notes for when this does go public at some point, a couple links to my blogs, explains sort of the background that I bring to this, and not exclusive, not in great detail, but it's like now there's the blogs, right? Once if I'm presenting this and I link, people are like, okay, so I can go to this sometime and read more if I want. This picture is a little bit on the funny side because obviously it's AI generated, and at this point, I warn or forewarn my audience that I do use computed imagery. I take it for granted. I have a whole video on that. Coming from a Python background, Python, the computer language, conferences in my background, a lot of slide presentations in my background. And these days, presenters throw together slideshows. They'll very commonly go to one of these image generators to just get what they want for that day's slide. It may be not something they keep, but I tend to curate my favorites. And so, anyway, I'll explain about AI if necessary a little bit. Depends again on the group. If I'm presenting to like the Arlington Club or something, they probably already know everything I do and more about all these AI things. So this is not a presentation about AI, it's a presentation about something called Synergetics. And I'm going to assume that the audience has zero knowledge going in. I'm just going to assume that. And like a lot of people, I think it's fun to hype sort of if there's a Himalayan connection, it's kind of like stereotypical for like somebody who has some esoteric occult, you could almost say occult teaching just to point back over their shoulder and say, and I learned it in the Himalayas. But this is something I collaborated with people in the Himalayas on some of these things in the 80s. And on the right, you've got a terribly abbreviated version of Synergetics, just the Jitterbug transformation, twisting left or right down to an octahedron, starting with a cube octahedron. It's like what? Well, at least and the high frequency, we could count the frequency. It's not that high, but the sphere on the left also gives the flavor of what is Synergetics. It's got visual cues, right? This isn't Bourbaki or anything. We have a lot of, I'm going to call it right brain. People may disagree, but hey, this is my presentation. So it's kind of a right brain visualization based, shall I call it a science exploration modality where you have these certain conceptual tools to help you. And what this orientation is about is here are the conceptual tools, preview, and now, do you want to know more? Do you want to take the longer course is basically what this is about. Like, not presuming that that's true. Like, maybe it's more of a turnoff for the majority of people who take this. But I do hear back to AI generated imagery, not by me, this one prompted by someone I've collaborated with a lot, and it's about a non existent state called Jefferson. We never had a Jefferson state, but there were people who wanted one. And that brings up the whole idea of kind of like virtual states, because all over the world there's people who wish they had their own state and don't. They're the lucky few who do, but there are all these, people who feel like they didn't get, or they got theirs taken away. Like, Yugoslavia, a lot of people are still patriotic for that place that no longer exists. A lot of them moved to Chicago. So Jefferson State is kind of an entryway to the topic of virtual nations or fictional nations, non-existent nations that nevertheless persist in the imagination, you could say. And Jefferson State, there's its whole history there. But then Cascadia, the context for Jefferson State itself, it's not like there's a governor of Cascadia or anything. It's a bioregion. But in our more ecologically literate subcultures these days, bioregion, river basin, we think in terms of ecology a lot more than we used to. So, anyway, there's a Lakota illusion here. I've done some Lakota training, sweat lodges and all that. So I feel immersed in this particular subculture. And I wasn't a gold rush guy, but hey, let's make sure that history's included. Talk about, the Oregon Trail, the whole thing. So place-based education, this is a slide where I would emphasize my pedagogy and andragogy is place-based. And then zooming back to the whole planet, check this out, a map you may or may not have seen, but it's all connected into this curriculum, a map of the world called One Island and One Ocean, and the subculture I'm coming from is very vested in this particular map. Way more than you might expect at first, right? And we could get into that, right? This is, again, just orientation, so I'm not trying to be, completely down in the details of every slide. I'm just saying overview. And coming back to the Wanderers again, Glenn Stockton, one of our Wanderers, he's passed away at this time, but very heavy contributor to the curriculum that we're talking about here. He coined his explorations as global matrix, right? Buckminster Fuller is the man behind the synergetics that we're talking about. Other people have also adopted that term. And Glenn Stockton, he could have called his thing synergetics too and jumped in that wading pool, or it's actually pretty deep pool. But, he did jump in, but with his own branding, Global Matrix. We used to hang out and compare notes. You could say Glenn's a very interesting character. In my blog, feel free to find out more about him. And, a lot of this is about relationships, networking, collaborating, because I have a model here of bringing people together and having these kinds of presentations that's spontaneously self-organizing and spreading without me. So I can, show you how I do it, but then I can inspire people to say, I want to use these slides too, and I want to go out there and do this kind of thing, but I want to put my own spin on it. I don't necessarily want to do any kind of verbatim rendering similar to or the same as what this guy's doing, Kirby. And I'm going to say on this slide, yeah, that's what I want too. Here's some slide decks I've thrown together that you are welcome to use and narrate as you see fit, right? Watch my examples, take what you can from them, learn from what you see me do, but I'm not trying to make clones of myself or anything like that. Although the slides, I think the fun part of it is that we do all use those same decks, and then it's easier to compare notes. Like, oh, this is how you do slide 21, right? And then you can always make your own decks. And, it's like with songs, right? The whole song as it is, or a canvas, a painting, it's not like your job is to go change the song or put more paint on somebody's piece of paint. It's as is, but then you can, take it as an influence and go off and do something different. So our curriculum here, this is where I start to, people say, well, this looks interesting, but I would never want to go this route. This is not my cup of tea. And that's fine. That's what orientation's about. It's like, well, I don't want to do this, but, why do I say it about this slide? Well, it's got a lot going on in terms of what software development looks like. This is an interactive development environment called Spider, and SPYDER, and it comes in a distro of Python called the Anaconda distribution, which is free. But what if you don't have a laptop? What if you've never developed and, you've never done software? Could this be a route? Well, you can, do read-only for a while, just like absorb. It's not like you have to install this immediately, but you might want to. And what I say in the notes here is if you want a max value from this courseware, you'll want to have Spider up and running so you can play with our Python framework. I'm reading my notes. Inexpertly. Other IDEs work too, of course. We're encouraging noobs to start with Anaconda, and even, okay, I gotta scroll a little bit to see all of my notes here. So I'm reading my notes, but when I'm doing the video track here, I'm just showing the slides without the notes. So I'm saying we're encouraging noobs to start with Anaconda, and even if you're experienced, you might want to try Anaconda and remove it later, easily done. So that's for people who already are sort of into this world of even just Python development, but don't use this particular environment. Now, what's going on in this slide, and others like it, is I'm using a framework. So behind the scenes here, but public on GitHub, anyone can grab it. There is a framework that lets us play with the polyhedra that this curriculum is all about. So it's very geometric, but what is different about it, why it doesn't hit the radar of a lot of people, because, Synergetics, what's that? I didn't have that in college. It wasn't offered. It does some bold revisions, or let's say enhancements, or let's say it branches or forks off from what we currently do in geometry. And what we currently do in geometry, I'm showing there on the left, that's a unit volume cube with edges 1. In Synergetics, our unit of volume is on the right there, the tetrahedron of edges D for diameter. So picture a ball, like a soccer ball, and think of how it has a radius from the center and it sweeps out a ball. The radius does. That's what we call R. Radius R, and then twice that all the way across the ball through the center is what we call the diameter. It's an axis. You can spin. Once you've got an axis, you can spin. You can get great circles from that. But without going there, I'm just saying the R in this picture represents the radius of such a ball. And how you fill space with balls, like when you have like 20,000 balls and you want to pack them together, how do you do that? Like we know how cubes pack together in a logical way, kind of in a bricky way. Face to face, we can fill space with cubes. That's obvious. Tetrahedrons, though, the regular tetrahedrons don't just face bond to fill space. They make interesting spirals, and irregular tetrahedrons, there are some that do fill space, even without left and right-handedness and blah, blah. But that's a whole discussion now. Like, why do we want this to be our unit of volume, and isn't it awkward? Isn't it going to be less usable? Isn't the cube a far more friendly shape to pin our thoughts to when it comes to what's a unit of volume? Why do we even want to leave the cube and go into this other world? Why? And so, that's the kind of thing a presenter will be asked. So when you want to become a presenter of this material, you'll have your answers ready at that point. One of the reasons is the nice volume numbers we get for other shapes, like the rhombic tricontohedron, which is what RT stands for here. And it shows up, what we do is we have a bunch of concentric hierarchy of polyhedra, we call it, or, it's like Russian dolls. We've got polyhedra within other polyhedra, not a new idea. Go back to the Renaissance for some of that. But the same polyhedron will show up relative to the others multiple times. So here we have the rhombic tricontohedron showing up 4 times and weighing in at different volumes. With 2 of these, now rhombic tricontohedron, you might be thinking, what the heck? What's it even talking about? So maybe I'll add a slide here. Like I say, this is still under development. That shows the rhombic tricontohedron in more detail. I think I need to add some more slides. And then on that note, I say, okay, so that's where I'm coming from. And now here's an example of the slides that I already have available to you for free that you could use. And I have some sort of, you could say, random slides from my other decks where I'll introduce Fuller's use of 4D as kind of a logo, Buckminster Fuller, kind of branded around 4-dimensional, which a lot of people were doing at the beginning of the 1900s. That was like in fashion. He wasn't the only one by any means. And if you've ever talked or know about or think about 4D, you might be thinking about Einstein at this point. Or if you're into machine learning and so on, you might be thinking about Hilbert space and polytopes and Coxeter. Wanderers last night, somebody had a bio of Coxeter, and we talked about his relationship with Bucky Fuller, which is an interesting story in itself. And he had a relationship with Einstein as well, Bucky did. When I say Bucky, I mean Buckminster Fuller. He liked to be called that. Here's his picture. On the right, where he's sitting next to his lifelong collaborator, Ed Applewhite, who I knew. I knew both of them, but I didn't hang out with Bucky. Applewhite and I would go to dinner and stuff. And he came to Portland, stayed at the Arlington Club, and with his wife June, and we hung out and stuff. So I see my entry point here of the people in this slide. I knew Applewhite the best, and Bucky, we corresponded and stuff. and we were in the same room together at Hunter College in New York City. There may be video of that at Stanford. That's where his papers ended up. And by papers, I mean artifacts. It's a huge archive, the chronophile. Fuller was very into self-documenting. He called himself Guinea Pig B, and he saved everything. And it got bigger and bigger, and it got to the point where when he moved from one institution to another, it was about negotiating like warehouse space for this chronophile, so-called, which he had leather-bound volumes for a lot of it. But a lot of it, again, is not just scrapbooks. It's, physical artifacts and so forth. But among all that, he also came out with a lot of published books. It's not just all like miscellanea in an archive. They're the published books, and we focus on those. And Synergetics is the 2 volumes, and here we're starting to get into it. That's actually a picture from Synergetics here. And we're talking about how he treats third powering differently, and that he doesn't picture it as a growing, shrinking cube. Third power growth for him is a growing, shrinking tetrahedron. And everything is triangles and tetrahedron oriented in his geometry, including, and this is since the publication of his volumes, people who are into Bucky have worked together on what we'll call the quadray coordinate system. That's still a hot area of research. In other words, there's a lot still going on with that. And how we redo a lot of our thinking once we have this unit volume tetrahedron, once we've made that move and tied it in with the sphere packing I was talking about, we get, when I say CCP ball centers here, for example, that's not Bucky jargon, that's crystallography. People already know what CCP is in a certain walk of life. And so picture me in like a senior center, and it's the kind of senior center where scientists tend to retire because they like to be with other retired scientists, and they already know what the CCP means. It doesn't mean the Cultural Center of the Philippines, and it doesn't mean the Chinese Communist Party in this particular context. And we actually do talk about name collisions and namespaces because we are getting into Python programming, and the idea of namespaces is core to Python programming and to computer science in general if you generalize. The word namespace actually becomes important in our jargon, and here there's more jargon on this slide. On the far right, that's actually the Jitterbug transformation again, but shown with spheres. Now, when I say again, what do I mean again? Well, memory, jog your memory. Way back here on the right there, that's a picture of the Jitterbug with straight edges with the rods. We're going from a cube octahedron at the top line, and then we're twisting either left or right to shrink it down to where it becomes an icosahedron. And then we can twist contract it even further to where it becomes an octahedron. And this kind of dynamic, this sort of animation you could call it, is very much in Synergetics. And that cube octahedron at the beginning of the transformation, you can show it as being formed from closest packed balls in the CCP arrangement, which you can see in the center. The animated GIF is 1, 12, 42, 92, 162, and so on. Layer by layer, we build outwards from a nuclear ball, and this is our matrix, you could say, where we do a lot of our thinking, is inside of this particular ball packing pattern, which I show in more detail here, and this is where the word frequency can start to be employed. We count the intervals along an edge here. So this would be a 2 frequency because even though there's 3 balls, the relationships are what we count. So one ball to the next, that hop, that interval, that jump, that connection between 2 balls, that is called an interval, we could call it. It's also the length d. In other words, the diameter of the ball is d, but so is the distance between 2 balls that are intertangent, right? From center to center, that's a d. distance hop, and so two of those hops, two frequency. We call this a two frequency VE, vector equilibrium, because the out pointing and in and around the in and the out. Well, let's save that discussion. Why we call it the VE, and just stick with frequency for now. Vector equilibrium VE. 1, 2, 3 frequency for this one. And so what is this? 10 times F times F. F is frequency. 10 times 9, 92. There are 92 balls in this layer. We have a formula for that. And 162 balls in this layer for frequency. So you see shop talk. Around each one of those balls now, you can imagine a concentric hierarchy of polyhedra. And the one on the right there, the blue 6, that's one of Kepler's favorite. That embraces every ball. So if we go back to this picture here on the far left, each ping pong ball, you could call it, in this picture is being contained by one of these rhombic dodecahedra, and they're face bonded to each other, and each one has a ball inside. That's why we call it a spheric sometimes. And its volume is 6 relative to an octahedron of 4, a cube of 3, and a tetrahedron of 1. Again, tetrahedrons are a unit of volume. Two of these tetrahedra fit into the cube as inscribed face diagonals that crisscross each other. I'm not saying that, that they're independent of each other. There's a duotech cube, we call it, which has face diagonals. This orange tetrahedron fits into the green cube as its face diagonals, is what I'm saying. But then we could have another tetrahedron, say a black one, that takes up the other 12 or 6 diagonals. Six faces in the hexahedron, right? And so these are nice volume numbers, I think you'll admit. That's one of the payoffs of going with this unit volume tetrahedron. And then it can get into more details. This is about how you can fit an icosahedron. If you see that, again, we're talking about the jitterbug. This first shape that you're looking at is an octahedron, the outermost shape. But inside of it, we're twisting a triangle from an internal cuboctahedron. Again, we kind of want animations here. And we're twisting it into an icosahedron. So like the jitterbug again, inside of an octahedron. And this is something that Piero della Francesca was aware of, and we talk about him in this curriculum. We have a lot of links to a lot of mathematicians, but also to a lot of philosophers and to a lot of humanities people like Hugh Kenner. So this is the CP Snow chasm. We might even set that up. You know what? I'm going to show you how to change the background color in Google Slides. What I like to do is pick the paint or the eyedropper and then pick a color from the slide. And I like the black background there. It makes it better. So this is called the CP Snow chasm. And on the left, you've got the sort of STEM, science, technology, engineering, and mathematics. And on the right, you have path, philosophy, anthropology, theater, and history. Theater and history. There's a difference. Theater can be fictional. History is what really happened. But then, of course, people fictionalize history all the time. So long discussion could be had about how, STEM is redundant as well, isn't it? Science, technology, engineering, and mathematics. You could put an A in there and make it STEAM. I like to say STEAM stands for anthropology. Most people say art, but I say A for anthropology, and art's part of anthropology. So I like that bigger umbrella. So yeah, there's the CP Snow chasm. This shows me generating this picture in a computer imagery computer. I say a deep chasm in the desert separates two groups of people. On the left, jolly jokers, wordsmiths, punsters, and poets. That's kind of a stereotype of how we look at the path side. So that's on the left, I'm thinking. And on the right are the MIT engineers with pocket protectors and slide rules. So you can't even see any of this. in the output picture, but the prompt itself is giving some information to the reader. I tend to use my prompts that way. I'll prompt for things because I know there might be a human reader, and there's going to be things that only the human will pick out from the prompt. And then there's going to be what's computed, which is what you see on the left. And the CP snow chasm is in between the great divide between the humanities on the left and the sciences on the right, and Synergetics aims to bridge the two. Synergetics is connected to the humanities world, to this gentleman, Hugh Kenner, in the middle here, a great scholar, and he wrote a book called The Pound Era. That's Ezra Pound on the left, James Joyce on the right. You may have heard of them. Ezra helped James Joyce in his career. Ezra was kind of behind the scenes helping a lot of people with their careers. That was one of his things. He was a networker. And a long story there. Like, we can get into the history of the Cold War and going back to Second World War and so on. We can use these characters as entry points, ways to get into the history. And I do that in other decks, but this is the end of this deck, the Steam Path integration that we claim Synergetics encourages. But again, we haven't really done everything that we could to make that true. I mean, to make that real for the listeners. Like, they may still have some doubts about that. I'm going to show you adding a slide now. So let's see. I'm going to insert, and I'm going to find another picture. This one's Renaissance inspired. I was thinking of Piero when I did this, Della Francesca, and this would be like, kind of a teaser to where you could think that there's more to this topic. It's more esoteric than we've gotten yet. Like, again, this is just sort of the ground floor. Do you want to keep going? Do you want to take more courses? Do you want me to come back? Do you want to do the next thing? Whatever. Depends on the context, how it comes across. Am I really offering to come back and do another course here, or is this all remote? These are the different, depends, right? Obviously. All right. So that's where we're going with Synergetics for Seniors. I hope that was interesting. Encouraging you to think along similar lines. Don't have to wait for me to make this public. For you to make a similar deck for your locale, right? It's not like you're waiting. I'm not the bottleneck. I keep saying that because I don't want to be. It's important information. I don't want to be seen as sitting on it. But on the other hand, I don't want to be too rushed about getting some of my stuff in ship shape before I launch it. So consider this a preview. And we'll talk to you soon. Bye-bye.